What if I told you there's one simple concept in Unity that can completely change the way you implement game mechanics? No need of complex code, just smooth, dynamic behavior that fits naturally into your gameplay. In this episode, we're going to dive into this powerful tool, animation curves. From fine tuning enemy movement to scaling difficulty and creating fluid transitions, this one concept will change how you approach your mechanics. Welcome to 100 Tips in Unity. This is episode 4. Let's curve right in. To create an animation curve, all you gotta do is in your script, you write public animation curve, give it a name, curve. That's it. This is all you need to do to add a curve into your scripts. If you go back, you will see a field for the curve. You can double click this to open the curve window. To start, you just simply hit the type of curve that you want. I'll double click this one and now you have a curve. And we can click on this point to edit the shape. Okay, we can add points by double clicking it, and then we can change the tangents. We can right click on these points to auto smooth it, or we can set the tangents to be linear if you want one tangent to be a straight line. You can do all the basic things with curves inside this editor. If you want an ease in and out, you can use this one here. Now, when do you need to use curves? You typically use curves when you need to do something over another thing. Okay? For example, if you want to increase damage over time. If you look at this curve, damage could be on the y-axis and time could be on the x-axis. According to this curve, when time is 0, damage will be 0. When time is full or 1, damage will be 1. Okay, the highest. So you could have an attack that just increases the damage the more you hold it. Or you could change the x-axis to be distance in your code to make it, hey, the further away the projectile travels, the more damage it gives. You can also go above 1 as well. You're not restricted to just go within 0 and 1. You can go above 1 if you want twice the damage or something like that. Everything is up to you. You can customize it. And this is great because it allows customization and flexibility. If you have different types of enemies, each enemy could have its own curve, and you can do whatever you want with it. So let's see how we can use this in action. Over in Unity, I have a very simple canvas. We have a canvas static which contains health text and a health bar canvas. You can check out the previous step in this playlist, which is about canvases, where we talk about having multiple nested canvases. So check out that video. The health field contains an image which has the image type set to filled, and we have a fill amount which we can set via code to animate this health bar. Over on the script, I have a simple health component. This health contains a few variables: max health, it contains current health, a recovery duration, a recovery delay, and it contains a reference to the fill image. At start, we get the fill image and then we update the UI. And update UI simply just updates the fill image's fill amount by current health divided by max health. So the fill amount is going to be a value between 0 and 1. Inside update, if current health is less than max health, which means if we are damaged, if we are not recovering, then we add a delay. This just waits for recovery delay number of seconds. That's it. Okay. And if we start recovering, we increment the recovery timer, and then we update the current health by max health divided by recovery duration, and we multiply it by time.delta time because we are inside update, and then we clamp the health so that it does not go above the max health. Okay, and we update UI. Again, it sets the fill amount. So this is very simple logic to update a health recovery. If I hit play, it is going to wait 2 seconds and then it is going to take 5 seconds to recover. So this is a delay time 1, 2, 3, 4, 5. It is 5 seconds and it is working very linearly. Now with curves, we can add a twist to it. We can make it work as if health recovery is slower in the beginning and it recovers faster at the end. Or we can make it the reverse. Health recovery starts very fast in the beginning, or it could slow down towards the end. We could control how recovery works over time. Okay? And the way we do that is by writing public animation curve. Let's call this recovery curve. If we go back, here's our curve. So we need to evaluate the y-axis based on the x-axis, which is time in this case. And how do we do that? Let's just say float recovery amount equals, this is the original amount, and what we need to do is we need to multiply it by a factor. So float recovery factor, and we're going to get that factor from this recovery curve. We can say recovery curve dot evaluate. We have a timer which keeps track of how many time has elapsed since we started recovery, which is recovery timer. We can simply evaluate by giving a recovery progress, which is a new variable, and we can say recovery progress is going to be recovery timer divided by recovery duration, and we are going to finally multiply it with this recovery factor, and we are going to add recovery amount to current health. Just to recap, we are going to calculate a recovery progress. This is going to be normalized value, which means it's a value between 0 to 1, which is going to be the x-axis value here. Then we evaluate a recovery factor from this curve by using the animation curve dot evaluate function. We pass in this x-axis value, and then we get the corresponding y-axis value by using this evaluate function. And we scale our linear health recovery, which is going to be max health divided by recovery duration. We are going to scale that with this recovery factor. And in this instance, recovery is only 1 towards the end, which means this will take longer than 5 seconds probably. And then we add to the current health. Let's see how this works. We will have a delay of 2 seconds, 1, 2, and it is going to start slow and it is going to take up the pace as we go forward. This is not smoothing at the top at the end. This is just recovery amount. I can just drag this here, sort of like this. So this is going to say 1, 2, and it's still not recovering because I've dragged that value, and it's going to recover very fast. See? Now you have a lot more finer control of how this thing works. We can have very high recovery in the beginning and have much lower recovery towards the end. And this is going to speed up recovery in the beginning and it slows it down towards the end. So you could see how realistic this could get. And we can have this curve for every entity of this health script, which is insane. The applications are endless. You can use this to increase enemy difficulty over time, or you can use this to increase damage of your projectiles over time or distance, anything really. Or you could have the player jump at a certain height at higher speeds. So speed could be on the x-axis in that case, and jump height could be on the y-axis. Essentially, when we have to do something over another thing, use curves. This is going to be super flexible. You can customize it to your liking. You'll have full control, and it's not complicated code. Of course, using simple variables is an alternative which uses less memory, but this one gives you extra flexibility. You don't have to go back and tweak the variables. You can just go ahead and tweak this curve to your liking, add points whenever you desire. If you are working in a team, this is one way where you can actually trick your game designers to actually do some more work. So yeah, that is the tip. Use curves whenever you have to do something over another thing. That's the simplest way to put it. This is mostly about the way you approach problems when it comes to mechanics. And curves are really good. The more you get used to it, the easier it will feel. I hope that video was useful. Let me know what you think. In the next video, we're going to talk about how to start profiling. It's going to be an important video for all developers. So take care. I'll see you in the next one. Bye.